All right, we are starting our anchor text. It's going to be really fun. We're talking about earthquakes by Sneed B. Collard III. Earthquakes. Essential question. This is big, so soak this in. You ready? Soak it in. How do people respond? How do they respond to natural disasters? Read how science can help people prepare for earthquakes. All right, so here we go. A shifting planet. We like to believe that the ground under our feet is solid and secure. People who have felt the ground shake know differently. They have lived through an earthquake. Earth's crust resembles a jigsaw puzzle more than a solid sphere. Like a puzzle, the crust is divided into different pieces that fit together. These pieces are called plates. Earth's plates float on top of a layer just below the crust called the upper mantle. The upper mantle is solid rock, but it behaves like a thick gel. Heat from deep inside the earth moves through the rock and causes it to slowly swirl and flow. Isn't that interesting? Myanmar residents inspect large cracks on a road after an earthquake struck the area. Look at that craziness. Wow. Wow. Yep. Dr. Inez Cifuentes is a seismologist, someone who studies earthquakes, right? So a seismologist is someone who studies earthquakes. She likes to compare the movement of Earth's plates to a boiling milk. When you boil milk, she says, you get that little surface layer of cream on top that moves and dances around. That's what's going on in the Earth, except that Earth's crust is much harder than a layer of cream. As the mantle boils, it pushes and pulls the plates above. It's at the edges of these plates, Dr. Cifuentes explains, where we have most earthquakes. So look at this is the Ring of Fire. It's right here. And these white lines represent Earth's plates, right? The Ring of Fire is where a lot of volcanic activity. The white lines on the map above show plates on Earth's surface. The red dots show where earthquakes have occurred. And I'm going to tell you, many of these red dots also will show where some volcanoes are too, volcanic activity. People stare at a gigantic crack on a street in Valdivia caused by the 1960 Chilean earthquake. Oh my goodness, look at that. Earth's largest quake. At first, a first-hand account, Dr. Inez Cifuentes became a seismologist for a very good reason. She and her family lived through the largest recorded earthquake in history. This was the 1960 earthquake that struck Chile. As Dr. Cifuentes explains, in April 1960, my family moved to Santiago, Chile. Just a few weeks later, on May 21st, we were woken up by strong shaking. Then, 33 hours later, a gigantic earthquake hit the southern part of Chile. And with it, an enormous tsunami about a year later. We took a trip to the northern end of the earthquake zone, and that's where I saw that the land had actually been raised up a meter or so. I saw these huge changes, and that impressed me, that the earth could actually do that. Later, as a graduate student, I wanted to know how big that earthquake was, how long it lasted, and whether it was preceded by a slow earthquake. I worked on this problem for 4 years. I was able to calculate that the Earth's largest recorded earthquake had a magnitude of 9.5. I also confirmed that a slower precursor or forerunner had occurred 15 minutes before the main earthquake. I am very proud of this work. So, yeah, she lived through this guy here. Look at the damage it did there. Whose fault is it? That's a play on words, right? Here we go. Earth's plates crash together, spread apart, and slide against each other. Wherever they do this, they cause breaks in Earth's crust. Seismologists call these breaks faults. Usually, the blocks of rock on each side of a fault just sit there stuck together. But when enough pressure builds, the two sides of the fault can suddenly shift or slip. This sudden movement releases waves of energy. These waves travel through the earth. We feel them as earthquakes. Most faults do not slip and cause earthquakes. Around the globe, however, active faults cause hundreds of earthquakes every day. Most are too small for us to notice. Once in a while, Earth unleashes a whopper. The diagram below shows a normal fault, which is a crack or fracture in Earth's surface. Movement along the fault can sometimes cause earthquakes. So earthquakes move in three different directions, or plates move in three different directions. Look at my hands. They slide against each other. They push toward each other. Or they pull apart from each other. Okay? The ones that slide like this, those are the ones that cause earthquakes. Okay? Measuring earthquakes. Seismologists record earthquakes using machines called seismographs. These measure shaking or ground motion. After an earthquake, scientists read their seismographs. They use their readings to calculate the earthquake's size or magnitude. Magnitude scales are set up so that each whole number is 10 times larger than the number before it. A magnitude 7 earthquake, for instance, is 10 times larger than a magnitude 6 earthquake. Truly giant earthquakes happen about once a year. These earthquakes with a magnitude of 8 or greater, they occur only on very large faults and can cause severe destruction. Dr. Cifuentes explains, the only way you can get an earthquake like the 2011 Japan earthquake is where one of Earth's plates is sliding under another one. This is the only kind of place where you have a fault long enough and wide enough to release that kind of energy. Seismologists gave the 2011 Japan earthquake a 9.0 magnitude. It was the fourth largest earthquake ever recorded. They believe that the earthquake occurred on a fault more than 150 miles or 250 kilometers long. It shook Japan for 3 to 5 minutes. That's unbelievable. It was so powerful that it altered the geography of the country. Surprisingly, it wasn't the shaking of the ground that did most damage. A massive wave proved much more destructive. What do we call that massive wave? Seismographs help scientists determine the magnitude or size of an earthquake. The disaster zone in Kesennuma, Japan, 2011, 100 days after the massive earthquake. Look at that. Look at those giant ships that got. Wow. Tsunami terror. When an earthquake occurs under the ocean, it often moves a substantial amount of water above it. This creates a fast-moving wave called a tsunami. Out at sea, the wave may only be a few feet high. As it reaches shore, however, the wave can tower into a monster. It can hurl water for miles inland. Tsunamis can travel thousands of miles. In 1960s, Earth's largest recorded earthquake struck the country of Chile. It produced tsunami waves up to 82 feet or 25 meters high along the coast. Wow. The tsunami also raced across the Pacific Ocean at a speed of more than 150 miles per hour. It struck the shoreline of Hawaii, Japan, Alaska, and other places. Hundreds of people drowned. In 2011, Japan earthquake produced a tsunami waves more than 30 feet or 10 meters high. The 2004 Indian Ocean earthquake in southern Asia produced 50-foot or 15-meter high tsunamis. These tsunamis engulfed entire cities and shorelines. The waves swept away buildings, cars, and people. Japan, southern Asia, and Chile had experienced many powerful earthquakes and tsunamis before. Why were so many people unprepared? Predicting earthquakes. Seismologists are very good at measuring earthquakes. However, they still can't predict when earthquakes will happen. There was a time, Dr. Cofuentes explains, when I think scientists felt that predicting earthquakes was just around the corner, that we were going to be able to predict earthquakes very soon. But it is clear now that it's not around the corner. In fact, some have given up entirely on predicting earthquakes. One reason that earthquakes are unpredictable is that scientists cannot collect enough information to understand where and when an earthquake might happen next. Although scientists have placed special instruments in many earthquake zones, earthquakes still surprise U.S. scientists. For example, had believed the next big earthquake in Japan would happen farther to the south, closer to Tokyo. Instead, it struck farther north. A powerful tsunami forced people to flee the roof of a control tower in a flooded airport. Look at that. Planning for earthquakes. Even though we can't predict earthquakes, we can prepare for them. Many seismologists help make information available to people so they can plan for and respond to earthquakes. This is especially important near coastal areas. Once the shaking goes on for more than 30 seconds, Dr. Cofuentes says it's pretty simple. You have to run away from the ocean and run uphill. You have maybe 15 or 20 minutes to reach higher ground. How cities are built also affects how many people survive an earthquake. Cities in many countries have special building laws. Buildings must be strong and flexible. That way they won't collapse during an earthquake. In some countries, however, buildings are often poorly built. In 2010 Haiti earthquake, for example, killed between 46,000 and 316,000 people. Unlike the earthquake in Japan, many of these people were killed by collapsing buildings and falling debris. However, earthquakes don't just destroy, they also create. They help make the mountains, coasts, and other landscapes we see around us. Dr. Cofuentes explains this is worth remembering as we learn how to predict and survive earthquakes in the future. Utility ducts like this one are being constructed to protect underground wires, cables, and pipes in the event of an earthquake. What to do during an earthquake? If you are indoors, drop to the ground and crawl under a sturdy piece of furniture until the shaking stops. Stay away from glass, windows, outside doors, and walls, and anything that could fall, such as a hanging light or fan. Stay in bed if you are there when the earthquake strikes. Protect your head with a pillow. Only move from the bed if there is a heavy light or fan above you. Use a doorway for shelter only if you know it is a strongly supported doorway. Stay inside until the shaking stops, and it is safe to go outside. Do not use elevators. If you are outdoors, move away from buildings, street lights, and utility wires. Avoid any space where there is falling debris, such as glass. Once in the open, stay there until the shaking stops. Students raise awareness about earthquakes by participating in a nationwide earthquake drill. About the author, Sneed B. Collard III. He believes that people can find science anywhere they look. His mother and father were both biologists, so Sneed grew up with exposure to science every day. He has written 40 science books for kids, many of them inspired by his own life and interest, including his frisbee catching dog, Today, he lives in Montana and enjoys writing about the American West and its natural beauty. Okay. So, there you have it. The anchor text read aloud.